What are containers? So it's probably more simple than some of you may think. Some of you might already know the answer to this question, but there's actually no such thing like one single thing that is a Linux container, right? Like we'd like to have this idea that a container is this, like we say, all right, Linux, containerify that and it just works, right? And it's not quite that simple. A Linux container really is actually a combination of at least 3 different kernel features within Linux that kind of culminate in this idea of what a container is. And again, this is going to be all here in the command line, so if you have any issues with it, go ahead and check out Jem's course on it. It's a great course. So before we kind of start getting into what is a container, I'm going to give you a little bit of the history of why we need containers, right? Like kind of lead you through the journey of how we got to where we are today. So I want you to picture for a moment that you are head of like a engineering team at a big corporation, right? And you need to host your website somewhere. I don't know how you became a head of engineering with no website already, but this is the situation that we find ourselves in for this hypothetical, okay? So if you had been, 15 years ago or 20 years ago doing this, you start thinking about like, all right, well, I need to buy a bunch of servers and I need to figure out where my data center is going to go, and I need to hire a bunch of people that are going to manage like racking and stacking servers, stuff like that. You can, as I call it here, you're working with the bare metal, right? So you're actually going to Dell, you're going to EMC, you're going to like some of these really big cloud providers, or not cloud providers, but hardware providers, and saying like, I need X amount of servers and I need these kind of things. And then you have to worry about like physical security of the data center. You have to worry about the temperature. You have to worry about upgrading things that go out of, like that are no longer powerful enough. You have to worry about all sorts of stuff like this. For me, the developer that just wants to sit here and write my JavaScripts all day, that sounds like something I very much do not want to do, right? But there are trade-offs here, right? There are still reasons that people do this, right? There are still lots of companies running on bare metal. I imagine many of your companies are still running on bare metal servers, right? It's more secure, right? Because you are not sharing anything with anyone, right? You control everything. You control your entire destiny. It's going to be, if you have these economies of scale, it can be cheaper for you, right? Than doing something like in the public cloud. And if you have anything that's extremely performance sensitive, like you can tune your boxes to be as, whatever you need out of them. But it comes with a lot of problems. This is expensive, right? You have to buy more capacity than you can use, right? Because if you're hitting your capacity, that means that you're dropping stuff on the floor, which means you always have to have more capacity than you're using. And a lot of us have seasonality to our apps, right? So if we have enough capacity to handle like Singles Day or Black Friday, that means you have a bunch of servers just sitting idle the rest of the year, right? You have to worry about stuff breaking, right? Like sometimes like RAM just goes bad, right? And then you have to go in and fix that. That's also still your problem now. And let's say you need to buy more capacity, right? It's not like where you can just say, hey, Kubernetes, give me another node, right? And you just have one. You have to call up Dell again and say, hey, I need more servers, right? I actually thought about writing a Kubernetes provisioner that like made a purchase request, right? And then eventually when it comes back and comes online, then it spins up your node, right? That's the worst idea and would be terribly expensive, and that's why I have not written it. I also don't have enough money to do that. So yeah, that only takes like a month or two, right? It's pretty much instant. So hopefully you're getting the point now. Bare metal has its ups, right? But it has a lot of downsides. There's a reason why a lot of companies don't do bare metal servers anymore. So let's get down into virtual machines then. So if I have like a web server, I'm running it on one server blade within my data farm, right? I'm running everything on bare metal operating systems like that. Well, what would be really cool is I could actually just have a farm of servers, and then I could have an arbitrary amount of servers running on them, right? And that's kind of where virtual machines come into the picture, right? So I can have one server, but I can have multiple different operating systems running at the same time as virtual machines, right? They're virtual servers in that sense. And that gets to be very helpful because now I can scale up and scale down within my capacity of my data center, right? And that's helpful because then I just have to manage capacity, because if I have like one team go offline, like they take down their service, I can then reclaim that immediately and add more stuff to it, right, from this other team that's coming online, right? So this kind of virtualization strategy allows us to separate VMs, right? At this point, we're still having to manage our own hardware, and we still have to manage our like operating systems and drivers and all that kind of stuff. But at least we can scale up and scale down within our own capacity. So let's talk about something else that this solves for us. Let's say that now we're running a hosting provider, right? Like some sort of like shared hosting provider. Let's say I had 2 different clients and I just dropped them both with root access to the same computer. And they're just say, all right, now run your servers. Now, if your skin's starting to crawl, good. It means that you already understand some of this, right? But if your skin's not crawling, let me make it crawl for you. So let's imagine that you have 2 soda providers. Let's say one of them's name is Coca-Cola and one of them's name is Pepsi, right? And Coca-Cola decides to store on their server recipe.txt, right? Now, hopefully you can see what I'm getting at here. If we have Pepsi on the same server, they could just change directory over into Coca-Cola's directory, say, oh, secret recipe, I got it. Great. I don't know why I made Pepsi the bad guy in this situation, but they're definitely the bad guy, right? All right. So this ends up being not great, right? So that's why virtualization can also help too, because now they're in like different operating systems. They can't even see each other, right? They don't even know that they're on the same server. To them, they're just like, all right, here's a copy of Ubuntu. You're just chilling out on Ubuntu, and that's it, right? We still have problems here, though, right? If I'm running a hosting provider and Coca-Cola and Pepsi are on VMs on the same computer, well, I could just have, if I'm Pepsi, I can just say, like, run a fork bomb within my particular VM, which consumes all of the resources and CPU and memory and all that kind of stuff. And it would take down the server, and it would take down everyone on the server, right? So that way they could cause downtime for Coca-Cola, and that would be a big problem. And like much less nefariously than someone dropping a fork bomb. And if you haven't heard of a fork bomb, I dropped a link in there. It's like a little short command that just takes down an entire system almost immediately. It's kind of fun. Don't run it on your own computer. But yeah, much less nefariously, you can just have someone that wrote a bug that leaked memory and took down the entire server. And you want them to just take themselves down. You don't want them to take down everybody, right? So that's kind of like we still have a problem here by just having the same people on VMs. Now with VMs, as you may guess, you can also limit how much, like, all right, you only get this many cores, you only get this much RAM, and you can kind of mitigate some of those solutions. But I'm going to show you how to do that even more with something called cgroups. So we still have a bit of a performance problem here as well. Like, it's not, let's say that I have 10 servers running as VMs all within like one racked server in my data center. But we still have some overhead here that's making this still like an inefficient system, right? We have to run 10 copies of, if we have a server that's running 10 different, like a Silicon server that's running 10 different like web services, right? We still have to run 10 copies of an operating system, and we're wasting some of that capacity on 10 copies of the operating system. It'd be great if we could just run 1 copy of the operating system, right? So this is what I'm hinting at with containers here. So again, if you want to play with VMs directly, GEMS course does that, and VMs are still very much a very valid option. Like, I know a lot of people out there are still using Azure VMs and AWS EC2, right? Very, very valid things still to be using, and there's still reasons that you want to use VMs, and so you should definitely play around with those as well. And like I said, GEMS course on Frontend Master does that for you, so I think he goes out and plays out with DigitalOcean. Okay, so that brings us to the public cloud kind of situation, right? So this is going to be like Microsoft Azure, Amazon Web Services, Google Cloud Platform, which you'll often hear me say GCP and AWS because I work in the business and I cannot help myself but use acronyms. I'm sorry. They've taken me. So this is great because now I've moved the data center away from my particular company, right? I no longer have to have like these like admins. I don't have to buy physical space. I don't have to worry about temperatures or anything like that. I just say like, hey, Amazon Web Services, or hey, Microsoft Azure, give me another VM and let me provision something. And those companies have massive data centers all over the world. Each one of them has like 30 or 40 different regions. So that's that's really great. We get the economies of scale here, and I just pay them for spinning the meter of how much CPU I'm using, how much memory I'm using, and they handle all of those servers for me. They handle updating the hardware. You never have to worry about hardware basically ever again. Now, but if you're still using VMs, you still have to worry about the operating system, right? They give you the server, but if there's a big security vulnerability, you have to patch it, right? Like you have to go in there and say, like, Ubuntu upgrade to the latest LTS or something like that. LTS stands for long-term service, I think. Support. Thank you. Long-term support. Yeah. And that just means that's a version that they maintain for a very long time. So public cloud, this is great. You end up paying perhaps a bit more than you would have running it yourself, but the trade-off here is you no longer have to hire people, and people are usually very expensive, right, to manage physical data centers, right? So that's kind of the trade-off. Usually it's almost always a good idea to be in the public cloud for that reason. It's usually cheaper from the human perspective. And it's getting to the point now that, like, you know, a front-end engineer can manage their own servers, right, which would have never been possible 15 years ago. So in these kind of situations, tools like Terraform, Chef, Puppet, Salt, things that we won't be talking about today because I don't know them and you don't want to learn them from me, these will be useful because this allows you to spin up servers, provision them, and when I say the term provision, what I mean is like install the correct software, make sure everything's up to date, you know, download your code, start running the code, all that kind of stuff. That's where these tools can be super useful for you. Definitely check them out if that's something that you're interested in doing. But we're still paying the cost of running a whole operating system in the cloud, and we still have to manage the operating system. It would be nice if we could just say, here's our code, here's the environment it needs, execute this, right? Here's this artifact of some variety, execute this. And that brings us to the idea of containers. Containers give us all of these security features and all these resource management features of like virtual machines, but they're much lighter weight, which is a term that I hate, but I'm still going to use here because it's an absolutely meaningless term, right? What is lightweight compared to what? Like, I feel like every JavaScript framework comes out is lightweight, right? It's the worst. But here I actually mean it, right? Like, you can say for sure that a virtual machine is lighter weight than running bare metal servers, and that containers are lighter weight than running a whole virtual machine. So basically what I'm doing is I'm just freezing like a file system, I'm dumping that into a container image, and then I'm shifting that off, and then I have some sort of host operating system that's executing these containers for me. So you're still going to have multiple things running in one host container system, right? And we kind of have like this same worry about like the Coca-Cola Pepsi problem that like I'm going to be running this container, and then next to me another container is going to be running, and I don't know whose it is or what it's doing, right? So I have these same similar concerns, but let me assure you that like with the features of containers, they can't see each other, they can't interact with each other, they can't even know that each other are there. And like a lot of very smart people have been working on this for a very long time, and I feel pretty confident saying that like this is secure and you should definitely go down this path. It didn't always used to be that way, it is now that way.